Good evening. Today's quote is pleasure in the job puts perfection in the work. Quote by Aristotle. Pleasure in the job puts perfection in the work. Today's word is nemesis, something that a person cannot conquer, achieve, etc. The performance test proved to be my nemesis. In Marathi, you can say योग्य आणि अटळ अशी शिक्षा किंवा पराभव, कर्मफळ, न्याय, अद्दल वगैरे वगैरे. Yesterday we discussed logarithm, but today I'll explain that part again. Now this is very, very important. See, we will be doing calculus in the second semester, and for that trigonometry and logarithm, these two topics play an important role. Okay. Now, let a raised to x be m. Here a is called as base, and what is x? X is called as an index or power or exponent, and m is the result. Now there is a restriction on the base, that base has to be greater than 0 but not equal to 1. Then in that case, index x is defined as logarithm of m to the base a. LOG is the standard short form of logarithm. Do not read this as log into m. Ideally, we should read this as logarithm of m to the base a. But we are idle, we just read log m to the base a. So LOG and m in straight line, and this is the base. In other words, what is logarithm? Logarithm is the power to which base should be raised. For example, just a minute. Students, they start. You should be here at 6:05 only. Okay. For example, what is 3 square? It is 9. So index 2 is defined as logarithm of 9 to the base 3. See, 3 raised to which number is 9? 3 square is 9. So log value is 2. Then what is 4 raised to 0? It is 1. So index 0 is log 1 to the base 4. What is 7 raised to minus 2? It is nothing but 1 upon 49. So index minus 2 is nothing but log of 1 by 49 to the base 7. Note that base is positive, not equal to 1. So whatever may be the index, answer is always positive. And we find logarithm of this positive number only. And therefore, logarithm of only positive number is defined. Logarithm of 0 not defined. Logarithm of negative number not defined. But note that log value, it being the index, can be positive, negative, or 0. So can I say that for logarithmic function, what is the domain? Suppose I define y as log x. See, base is not written. This does not mean baseless logarithm is possible. Logarithm definitely has valid base. But here I want to tell you about domain and range. Domain means set of all values which can be assigned to x. We know that logarithm of only positive number is defined. So domain is r plus set of positive real numbers. And what is a range of the function? Range means set of all possible values. Note that log value can be positive, negative, or 0. And therefore, what is the range of logarithmic function? Set of real numbers. Some students argue that minus 3 cube is minus 27. This argument is correct. But then they say that, so log minus 27 to the base minus 3. Why can't this be 3? The reason is simple. Logarithm is defined. See the word defined. Logarithm is defined if and only if the base is greater than 0, not equal to 1. Now minus 3 is not greater than 0. So this is true that cube of minus 3 is minus 27. But this is absurd. I hope this is clear to you. Now base of logarithm plays an important role. See, if base of logarithm is 10, we have already discussed this. It is called as common logarithm. It is called as common logarithm. And it is used in log tables. We have discussed log tables. If base of logarithm is e, it is called as natural logarithm. Now, naturally, you will ask me, what is e? See, e is an irrational number. So if it is a number, it will have certain value. Yes, it has 2 less than e less than 3. How it comes, we are at present not interested in this. I'll definitely upload the video regarding e, or we will listen to that in the next lecture only. So what is e? E is an irrational number, 2 less than e less than 3, and approximate value is 2.7182818. Okay, so this is about e. Now logarithm has base e in calculus. Now you know about calculus, that is limits, derivatives and integration. So in common logarithm, base is 10. In natural logarithm, base is e. On scientific calculator, you must have seen 2 buttons. On one button, log is written, means common logarithm, and on the other, ln is written. Ln is the standard short form for natural logarithm. But generally, in calculus, we just write log x, because there it is customary not to mention the base of logarithm if it is e. So log x means log x to the base e. Now base need not be e. So if it is other than e, then we mention it. Okay. So this is the convention. So this is about logarithm. Now there are rules of logarithm. Let me explain them. The first one, basically why we use logarithm. Actually, nowadays we do not use logarithm for calculation purpose because calculators are available. But previously, when calculator was not available, logarithm was used for simplification part, because logarithm helps us to convert multiplication into addition and division into subtraction. It doesn't mean that 15 into 7 will be now 15 plus 7. No. Logarithm of 15 into 7 is logarithm of 15 plus logarithm of 7. Similarly, using logarithm, division is converted into subtraction. And most importantly, if we are asked to find, say, 1.7 raised to 13, that can be obtained easily using log tables. Okay, so let us discuss rules of logarithm. If you want, you can write, but I have already uploaded the notes. In fact, I can show you that. See, this file I already uploaded on day 1, logarithmic function. Then this is the graph. We will discuss this also. And these are properties of logarithm. I'm saying rules of logarithm or theorems. Now the first one is log mn. Log mn is log m plus log n. See, I'm not mentioning the base. Any valid base can be considered. Whatever is the base on LHS, same is the base on RHS. Baseless logarithm is baseless argument. So logarithm of product is not product of logarithm. It is sum of the logarithm. Now people who read this as log into m, they may take log common from right hand side to get log into m plus n. That is ridiculous. This is not log into m, this is logarithm of m. So sum of the logarithm is logarithm of product. That is logarithm of product is sum of the logarithms. Proofs are not required. Log of m upon n is log m minus log n. That is logarithm of quotient is logarithm of numerator minus logarithm of denominator. Similarly, what is difference of logarithm? It is logarithm of the quotient. Now, third part is important. Logarithm of m raised to n is n into log n. This is very, very important. Logarithm of power is that power into log value. That or you may say a number multiplied by log of a number multiplied by log is logarithm of that number raised to this multiplier. Okay. Note that log of m raised to n, I hope you get this. See, this is log of m raised to n and this is log m raised to n. That is product of log m how many times? N times. So these are not same. N log n can be written for log of m raised to n. Okay. Now this is important. Change of base. We will verify this. Change of base. See, as I said that in calculus, base of logarithm should be e. If it is not e, we cannot say that that is absurd or wrong, but we have to change the base to e. So let me mention that change of base rule. Log a to the base b. Suppose we want to change the base from b to c, then it is log a to the base c upon log b to the base c. Quite logical. We are going to verify this also. See, logarithm of any number to the old base, logarithm of any number to the old base equal to what? Logarithm of the same number to the new base divided by logarithm of old base to the new base. Now from this we can easily obtain that what is log a to the base b? It is 1 upon log b to the base a. Observe that a and b are interchanged. Now we will verify these two. Suppose log 100 to the base 10. Now I want to change the base from 10 to 100. So as per this theorem, what is log 100 to the base 10? Let me put a question mark here. Log 100 to the base 100 upon, because we have to verify this, upon log of old base to the new base. Okay. Now, left hand side. Log 100 to the base 10. Logarithm is the power. To which base should be raised? 10 raised to which number is 100? 10 square is 100. So this is nothing but 2. Okay, 2. Now we have to verify this. This part. What is log 100 to the base 100? Logarithm is the power to which base should be raised. Every time you have to say this. 100 raised to which number is 100? 100 raised to 1 is 100. So 1 upon log 10 to the base 100. Logarithm is the power to which base should be raised. 100 raised to which number is 10? 100 raised to half. Square root of 100 is 10. Square root means raised to half. Now, can I say 2 is 1 upon half? Yes, I can. Right? So this is just the verification. So this is not proof. This is just the verification. Okay. So we have verified that log a to the base b is log a to the base c upon log b to the base c. Now, this is interesting. I'm saying that this is the corollary of change of base rule. Just a minute. Okay. Now, this is the rule. Okay. Now, can I say that change the base to a. I'm talking about this. So it will be now log a to the base b is log a to the base a. But log a to the base a is 1. Why? Logarithm is the power to which base should be raised. See what I'm saying? I'm saying change the base to a and not to base c. So log a to the base a, 1. And denominator log b to the base a. I hope you are getting this. Okay. So again, I'm saying log of any number to the same base is always 1. Can you tell me what is log 1? Log 1 to any valid base is always 0. Suppose base is 10. 10 raised to which number is 1? 10 raised to 0 is 1. Right? So this is about the rules of logarithm. Now let me ask you one question. I'm saying that what is logarithm? Logarithm is the power to which base should be raised. Now, 1 raised to 1 is 1. 1 raised to 0 is also 1. So tell me which of these two values is correct. I repeat the question. What is logarithm? Logarithm is the power to which base should be raised. 1 raised to 0 is 1. 1 raised to 1 is also 1. So type your answer in chat box. Which of these two values is correct? Type your answer. Most of the students have given correct answer. Very good. See, you should take objection to this only. How can base of logarithm be 1? See, logarithm is defined if, oh, what is this? Logarithm is defined only if base of logarithm is great. What I'm doing? Just a minute. Base of logarithm is greater than 0, not equal to 1. Right? So correct answer is log 1 to the base 1 is not defined. Very good. Now we'll go through this. This is, as I said, already uploaded on website. Actually, before we discuss logarithmic, I should have told you about exponential function. Let me explain that. Oh, yes, just listen to me, don't write. Exponential function, a function of the form f of x equal to a raised to x, where a greater than 0 is known as an exponential function. Y equal to 2 raised to x, y equal to half raised to x, y equal to 3 raised to minus x are exponential functions. Now, graphs of y equal to a raised to x, where a greater than 1, a less than 1 are as follows. So, graph of y equal to 2 raised to x and that of y equal to half raised to x. So, this is the graph for 2 raised to x and half raised to x. Okay. Now, functions e raised to x and e raised to minus x are again exponential functions. E is an irrational number whose approximate value is 2.7182818. So this is about exponential function. What is the domain and range of exponential function? Okay. Before that, this is the graph of y equal to e raised to x and this is the graph of y equal to e raised to minus x. See, when x equal to 0, what is y? E raised to 0 in both the cases, which is 1. That is why both the graphs intersect at this point, 0, 1. Yes, for exponential function, what is domain? Set of real numbers. Actually, is this correct? Domain is set of real numbers, because here they say, just a minute, that in exponential function, okay, yes, domain we mean set of values which can be assigned to x. Function is a raised to x, right? So index can be any real number, and that is why domain is set of real numbers. And what is the range? See, if base is positive, whatever may be the index, it is going to be positive. and positive real number is written as open interval 0 to infinity. So for exponential function, what is domain? R, and what is range? It is set of positive real numbers, which can also be written as an open interval 0 infinity. Now, we have already discussed this. Let me read. Logarithmic function. If x equal to a raised to y, see, this is very, very, very important. Base is greater than 0 and not equal to 1. Then and then, y is called logarithm of x to the base a and is written as y equal to log x to the base a. It is clear that if a is greater than 0, a raised to y is always greater than 0. Thus, log x to the base a is defined only for x greater than 0. So, logarithm of 0 not defined, logarithm of negative number not defined. So, f of x equal to log x to the base a is called logarithmic function. We have already discussed this. Now, what is domain? Domain means set of all values which can be assigned to x. We have just seen that logarithm of only positive number is defined, and that is why domain is R plus. R plus can also be written as open interval 0 to infinity. And what is range? Set of all logarithmic values. Log value can be positive, it can be negative, it can be 0 also, since it is the index, and therefore what is the range? It is R. Okay, so the graphs of the functions are drawn. This is function log x to the base 2, and the second one is log x to the base half. Now this won't be asked in exam, but in physics and even in chemistry and biology, exponential curves, logarithmic curves are mentioned. So this is the graph of logarithmic, and we have already seen graphs of exponential functions. Properties of logarithmic function. Log m to the base a is log n to the base a, then m is n. Yes. Log 1 to the base a equal to 0. Log of any number to the same base is 1. This is interesting. This is interesting. Fourth one. A raised to log x to the base a is x. I repeat, a raised to log x to the base a is x. We will be using this at least 20-25 times in calculus. Let me explain that. See, suppose a raised to m equal to x. Okay, then what is m? Index m is defined as log x to the base a. Now put this value of m in this one. So I get a raised to log x to the base a equal to what? X. As simple as that. A raised to log x to the base a is nothing but x. Okay, I'll take one particular example. No problem. I want to find value of, say, 3 raised to log 27 to the base 3. As per this result, expected answer is 27. Let me check. Log 27 to the base 3. Logarithm is the power to which base should be raised. 3 raised to which number is 27? 3 cube. So this value is 3. So we get 3 cube. Is 3 cube 27? Yes. So fourth result is important. Then what is log mn? Log n plus log n. What is log of m upon n? Log m minus log n. What is log of m raised to n? N into log n. Result number 8, change of base rule. I already explained this. We have verified this also. Log a to the base b is 1 upon log b to the base a. See, it is by writing only you can remember this. See, when a teacher explains, you definitely understand that, because usually teacher has the experience of teaching for more than 15-20 years, but that effect is just temporary. For permanent effect, you have to write this result at least 10 times. Result number 10. Logarithms to the base 10 are common logarithms used in log tables. Logarithm to the base e are called natural logarithm. Can you tell me one more name for this? It is called as Napier's logarithm. Okay. Now result 1213. You can read these two results also. So this is about the rules of logarithm. Now try to find log 81 to the base 3 root 3. Actually, we do not know the value, so we say let the value be x. Now this is in which form? This is called logarithmic form. We write the same in index form. Logarithm is the power to which base should be raised. So 3 root 3 raised to x must be 81. Note that index is a variable. So we must try to write this with the same base. Now 81 is 3 raised to 4. What is root 3? 3 raised to half. Laws of indices. 3 raised to 1 into 3 raised to half is 3 raised to 3 by 2. So 3 raised to 3 by 2 raised to x. So 3 raised to 3x by 2 equal to 3 raised to 4. Now base is the same. So equate indices. So 3x upon 2 is 4. So x equal to 8 upon 3. Is that clear? Right now. Exercise 6.1, 17th sum rather. Express the following exponential equations in logarithmic form. I have made a table, but before that, this is very important. A raised to x equal to m. This is index form. X equal to log m to the base is logarithmic form. These are two equivalent forms. So whenever you solve sums on logarithm, it is better that you write these two forms. Given one form, we can express the same in another form. First one, exponential form, 2 raised to 5 is 32. So it is 5 log 32 to the base 2. Now start writing. What is B part? 54 raised to 0 is 1. So index 0, every time you have to say index 0 is log 1 to the base 54. Now complete the remaining. So this is comparatively simple one. You can check the answers. By the way, can you tell me approximate value of x? Log 6 to the base e. Can you tell me the approximate value of x? Between which two integers x will lie? See, this is mathematics. I repeat the question. Log 6 to the base e is minus x. Now you have to tell me between two integers will the value of x lie? See, my question was log 6 to the base c is minus x. So x lies between which two integers? See, we know that e raised to 1 is 2.7 and e square is approximately 7.3. Now 6 lies between 2.7 and 7.3. So log value will lie between 1 and 2. But log value is minus x. So minus x lies between 1 and 2. My question was, in which interval does x lie? So we need x. So multiply by minus 1. If multiplied by negative number, inequality reverses. So minus 1 greater than x, greater than minus 2. Now this is tail and this is head. I have written minus 2 first. So tail towards minus 2. Minus 2 less than x less than minus 1. So x lies between minus 2 and minus 1. Is that clear? Sum number 18. Express the following logarithmic equations in exponential form. This is again simple one. I have done A part only. Remaining sums for homework. Tomorrow I'll tell you the answers. Log 64 to the base 2 is 6. Now logarithm is the power to which base should be raised. So 2 raised to 6 is 64. Here you can verify also. Product of 2 6 times gives 64. Sum number 19. Find the domain of f of x equal to ln x minus 5 means what? Natural logarithm of x minus 5, of course, to the base e. Now logarithm of only positive number is defined. So f is defined only if x minus 5 is greater than 0. That is x is greater than 5. Till what? Till infinity. But is infinity a real number? No. So you have to say open interval 5 to infinity. Better. Now B part, f of x is log of x square minus 5x plus 6 to the base 10. See, f is defined I double f. I double f is the standard short form of if and only if. X square minus 5x plus 6 is positive, means greater than 0. Now, x square minus 5x can be perfect square of x minus 5 by 2. Why 5 by 2? Why not 5 by 11 or any other number? The reason is simple. When you square, it is always 2 times the product. Had it been 11 times the product, I would have divided by 11. Now square this. X square present minus 2 times the product present plus 25 by 4. We have unnecessarily added that. So subtract plus 6 as it is. Now minus 25 by 4 plus 6 is minus 1 by 4. Shift to other side. So x minus 5 by 2 square is greater than 1 by 4. Now I have explained this at least 10 times. How to solve x square greater than a square. If you want, you can write x square greater than a square means x less than minus a, or don't write and, or x greater than a. Here a square is 1 by 4, so a is half. Now add 5 by 2. Minus half plus 5 by 2 is 2. Minus 5 by 2 shifted to RHS plus 5 by 2 plus half, that is 3. So x should be less than 2. Now you will understand the reason why not to say and. The number which is less than 2, can it be greater than 3? Impossible. So x less than 2 or x greater than 3. Now how to write this using interval notation? Open interval minus infinity to 2, union 3 to infinity. Now this is number line. You need not write this in exam. This is sufficient. So this is the domain. Now question 20. It is just application of rules of logarithm. Write the following expressions as sum or difference of logarithms. First one, A part, log of PQ upon RS. Basically, what is log of M upon N? Log M minus log N. But this itself is product. What is logarithm of product? Sum of the logarithms. Do not forget to put this in bracket. Otherwise, you may write minus log R plus log X. No, you have to multiply both the terms by minus 1. Okay. So final answer is log P plus log Q minus log R minus log S. B part, log of root x into cube root of y. Root x means what? X raised to half. Cube root means raised to 1 by 3. Log mn is log m plus log n. Log of m raised to n, n log m. So finally, it is half log x plus 1 upon 3 log y. C, ln means natural logarithm. A cube square of a minus 2 upon root b square plus 5. What is log of m upon n? It is log m minus log n. Now root means raised to half. Now what is logarithm of product? Sum of the logarithms. And what is logarithm of power? That power into log value. So 3 ln a plus 2 logarithm a minus 2, natural logarithm. I hope you will not open the bracket. This cannot be simplified further, remember. And this is half ln b square plus 5. So that's it for today.